Hello, I just created this meeting to capture some facts related to OpenShift logging. Um, so to start with, I have an OpenShift cluster. I have created a project called sample project. Okay, this is the UI and here is the command line. I already logged in OC get project. Okay, um, so this is the project that I had created. OC get pods. I already logged into the cluster, so I don't have any pods running. I don't have any deployments yet. Okay, so let me go ahead and create a deployment. I'll just use a busy box and dumps few logs onto the std out and std error and see what happens underneath. Okay, so initially I'll just demonstrate few facts. Okay, facts like, con1 is the process actually capturing the logs and creating the file. Logs are produced in var-log pods. Kubelet is the process actually rotating. So these facts I will demonstrate right now. So let me go ahead and create a deployment. Okay, let me call this as busy box. Namespace is okay. Image, I'll just use a busy box image. It doesn't listen on any parameter. The busy box has to be given something to do all the time. So what I can do is give it a command. What to cat. Let me go resolve.conf. We know that such a file exists within the busybox container. So this puts the output onto the std out. In addition, let me go ahead and cat a file that doesn't exist. So cat will then write to std error. So basically what we are having here is something writing to std out and something writing to std error. And after that, we can sleep. Okay, let's go ahead and create this. The 3 replicas, you probably don't need 3. You can reduce it to 1. 1 pod is fine here. Let's check out what's happening with the pod. We have one busy box container running. So let's go and look at the output. Even the result.conf is probably I did not spell it correctly. So I can go into the terminal, go into hc resolv.conf. Okay, that is correct. So maybe I misspelled it. Okay, that's saved. The pod is restarting. If I go into the pod, okay. Now we are getting data both from the std out and std error. Although on terminal we'll be able to see both entries. So let's look at in the background what's happening. First, I need to log into the node where the pod is running. So I'll go into this node. Okay, and OC debug node. Okay, I'm in the pod right now. I will go into the host, which is the node. If I go into where logs, where log parts, I can see a sample project. Okay, here my busy box container is running. There are other namespaces and pods running on this node. I'll just go into this node, and here we see one log file. I don't think this is actually the log file generated by the my container is probably the conmon which is creating it. Now I go into, as you can see, the logs are generated under a folder which has my namespace and the pod name, again probably the container ID and all the stuff. Okay, and you can see there's a lot of log files getting generated. 0.log. So we have to know which process is actually writing the logs. Okay, we can run fuser on it, and if we 0.log, okay, it is being 2761848. Okay, ps minus ef grep 2761848. Okay, that's for the conmon. Conmon is a process started by the container engine. For each and every container, it starts a conmon process, and it has been given a lot of parameters like the log file name and a log level and all those some default parameters that's probably come standard with OpenShift or Kubernetes. That's given as arguments to the conmon. And conmon actually what it does is it captures the output generated by the container, both std error and std out, as two separate streams, and it's creating the 0.log file. I'm in this folder already. That's why I can see this 0.log file, and I can tail this. Uh, when I tail this, you can see std out and std error coming as two separate entries in the log file. Okay, so there's no chance of std out and std error getting mixed. It's coming as two separate streams. In fact, conmon captures this std out and std error two separate streams. When it writes, it puts the timestamp and then the std error and f. I don't know what f stands for, and then writes down whatever is generated by the container on the std error. Here, whatever is generated by the container on std out. And it appears to me that each line is created as a separate entry in this file. The separate entry in the sense the timestamp and std out and f has been prepended before writing. Okay, so you can already see that there is some housekeeping going on. 0.log, and there's this gz and this plain file. So kubelet, what it does is once it reaches some size, I guess it's related to size, um, it copies that log file and regenerates and generates another 0.log so that conmon can start writing onto the 0.log. And any agent like fluentd or filebeat can be picking up the logs from 0.log and centralizing it. So we did talk about the concepts that conmon is the process creating the logs. I know this because I ran fuser on 0.log. Okay, okay, and I found out the process ID and did a ps minus ef, and that's how I know that conmon is the actual process writing the logs. Conmon is the parent process of the container. That's I know this because here you can see the process ID, and this is the actual container, and that's the conmon is the process which is the parent of this container. And the logs are produced in Verilog parts, and we just saw that. Kubelet is the process rotating those. How do we know this? So let me run fuser because we have to catch it at that particular interval. Like right now, you can see that kubelet is in the process of actually renaming the logs and also archiving the logs. Okay, if I do a fuser on gz, It's already created. No process is actually using it. Okay, but at some point of time when 0.log reaches some maximum number, kubelet starts rotating the log. So let's wait for it. Currently, when it's running fuser on all the files, and we see only conmon being listed, the conmon process ID being listed. If we wait for a few minutes, we will see kubelet IP, sorry, PID also getting listed. So let's wait for a few minutes. While we are waiting, would you like to talk about whether is it the right design that kubelet would it be tasked with rotating the logs? In my view, I think kubelet being the critical component on the node, it should be a separate process actually rotating the logs just in case this log rotation results in. Okay. Uh, you can see I just stopped the while loop where we're running an fuser on all the files. You can see the 0.log dot the timestamp was rotated by a process with PID 1550. Okay, if I run a ps minus ef on this 1550, you can see that it's a kubelet. And kubelet is making this decision maybe because there are some default parameters on when to rotate the logs. Now, as I said earlier, kubelet should not be in the main path of rotating the logs. In my view, that's not the right design because it's a critical component. If something is going wrong with rotation of the logs and kubelet is hung, uh, then nobody can do a OC debug node and log into the node because kubelet is involved in that OC debug node. It should just delegate this to another process, or in fact, if conmon does it, that's better. Conmon does have options to rotate the logs, but kubelet is not making use of it. Maybe because uh, kubelet has to work with various type of container engines, and some container engines do not offer this features. Maybe I don't know whatever the reason, but kubelet should not be in the process of rotating the logs. It should be delegated to a child process. And one other problem I like to highlight is conmon is generating the log file and kubelet is rotating the logs. Okay, there could be a race condition, especially when conmon gets too busy writing the logs. It can happen when an application is generating too much of logs and conmon is very busy and does not relinquish control of the file. Okay. Uh, I can demonstrate that also, but let's focus on this kubelet. We just found out that kubelet was the one responsible for renaming the log file and also archiving. We did this by running fuser on all the files that's getting generated and then found that the PID that was actually creating this file was kubelet. And with that PID, we just found out that is the kubelet. And if you look at the command line parameters, there's no log file size. I don't see any max size or something like that. All I see is a config file. Okay, kubelet.conf. So let me look at the conf file. Okay, there is some default value, container log max size 50 MI. I guess that means megabytes, 50 megabytes, bits. I don't know. In any case, that's the max. It's being rotated based on the max size. And yeah, we demonstrated all these concepts. Okay. The question is, when does the kubelet decide to rotate the log? It should catch and if there is a separate agent like fluentd or filebit which is actually picking up the logs, and if it has not done picking up the logs for whatever reason, and rotating the log within that time frame would result in log loss. So there has to be some kind of a determined behavior or some kind of an SLA agreed between this uh, um, kubelet and the agent that's actually tasked with centralizing the logs like fluentd or filebit. There's no handshake between the log rotation. We can just okay. One other thing I like to highlight is when user runs a kubelet or a kubectl get logs, where does the logs gets picked from? Does it get from 0.log or does it get picked from this as well? That is not clear. We need answer for that. And one more thing I like to demonstrate is yeah. So let me go ahead and kill the pod. So we are in this folder. Okay, let me go out so that okay, here deployment. Let's scale down to 0. Still terminating. So let's look at what's happening with the logs. This busy box is still there. So the logs are gone. So let's say the container dies for some reason, the pod dies for some reason. Kubelet doesn't know whether the file beat or Fluentd has already centralized the logs. So just deleting the logs just because the pod is not there, is it because I don't know how this is working? Is it because it's a this cluster has been built to do that, or when does the actual pod logs gets deleted by kubelet? That's not clear. And how does it know that the file beat was able to centralize it? So these are some of the things I wanted to demonstrate. I can stop the meeting now. Thank you. Rest of the comments we can discuss over the meeting.